Good morning students. Now we are studying the chapter electricity, in which we know what are the different types of charges, what is electric potential, what is potential difference, and what is current, and then we study Ohm's law. This is a very important law. Actually the numerical of the whole chapter is based on the law, that is Ohm's law, in which we find out the relation between the V and I. Since we know that V means potential difference is directly proportional to the current. So by using the Ohm's law, we find out the formula V is equal to I into R, where R is the resistance. And we know that the resistance means which resists the flow of electron. Actually what is the current? Current is the flow of charges. And what are these charges which moves here, which flow in the circuit, is the electrons. So the resistance is which resists the flow of these electrons is called the resistance. So some of the conductors have the high resistance, whereas some have the low resistance, and the insulators have a very high resistance, and due to which they are not conduct electricity at all. So we are studying resistance now. The resistance having the SI unit Ohm. We represent it by the symbols like this, the symbol of headphones. So this is called the resistance, and you can write it the definition of the resistance like the property of a conductor due to which it opposes the motion of charges or the electron is called resistance. We represent the resistance by the symbol R, and its SI unit is Ohm on the basis of the name of the scientist Ohm, which will be represented by this symbol. This is the symbol of Ohm. We can find out resistance by using the formula V is equal to I into R, and R should be equal to V upon I. So you can see that the resistance is dependent on the potential difference of the current. No, it's not dependent on both these things. Actually, resistance depends on the other things, and we will discuss it about later. So we can find out the value of resistance by finding the potential difference as well as the current in the circuit. So these are not the factors on which the resistance depend, but we can find out the resistance of any wire by finding the potential difference and the current flowing through this wire. So let's take an example of resistance. A simple circuit has 24 volt battery and has resistance 60 ohm. So it means the potential difference is how much? 24 volt, and having the resistance of 60 ohm. So here we have to find the value of current in the circuit. So by using this formula V is equal to I into R, we can find out the value of I is equal to V upon R. V is equal to V is 24 upon 60. 6,424. 0.4 ampere. So this is the value of current. A simple formula we can use for finding one of the value of R, V or I. If we know the other two values, we can easily find out the value of third one. Okay, I don't remember have I discussed this numerical in the last video or not. So okay, doesn't matter. I explained the question now. Okay, it's okay. If I did not explain the question, then I am going to explain one more question. An interesting question. An electric iron draws a current of 3.4 ampere from 220 volt supply. Current is how much? It is 3.4 ampere. And what is the value of potential difference? It is 220 volt. So here you know the value of current flowing through the circuit and the value of the potential difference. What current will be electric iron drawn when connected to the 110 volt supply? You know, by changing the potential difference, the current also changes. According to Ohm's, he said that V directly proportional to I. It means if we increase the potential difference, the current will increase. If we decrease the potential difference, current will decrease. So here in this case, we are going to change the potential difference of the circuit. Then there should be some change in the current. Then how can you find how much current is flowing now when you connect the circuit with a 110 volt supply? So one thing you should know that if you change the potential difference of the circuit, the resistance of the wire do not changes. It means this is a property which is not depends on the I as well as on the V. The resistance of the wire do not depends on the potential difference or the current flowing through it. So if we are going to change the potential difference in the circuit, the current will also changes. So you can say that from the first part we can find out the value of resistance, because the resistance is the constant value, it is not changes. So we can find out the value of R by using the Ohm's law. R is equal to V upon I. It is 220 upon 3.4. So this is the value of resistance in a circuit. Now by changing the potential difference, since the resistance of the wire not changes, so we can easily find out the value of current by using the Ohm's law. It is V is equal to I into R, so I is equal to V upon R. Now the value of V is 110 and divided by the resistance. The resistance is 220 upon 3.4. You know this value is not changes or changing the potential difference. So you can use this value divided by 220 upon 3.4. We can calculate it. We know that if we want to make it multiply, we have to reciprocal this term. So by calculating, we will get 1.7 ampere. This is the amount of current flowing through the circuit if we reduce the potential difference up to the 110 volt. So this is the question. Nice question. Now let's discuss the graph between the V and I. You will draw the graph between the V and I in your practical, but I am going to explain the graph between the V and I. You know that V and I are directly proportional to each other. If you increase the potential difference, the current also increases. If you decrease the potential difference, current also decreases. So this is the graph between V and I. This type of graph is always obtained between V and I. If we change the potential difference, if we are going to increase potential difference, current also increases. Like this. Or if you are going to increase the current, the potential difference also increases. It means potential difference and current is directly proportional to each other. So we can say that the graph between the V and I should be the straight line inclined with certain angle with the axis. This is the x-axis and we are representing the x-axis by the potential difference and we are representing the current on the y-axis. So if we draw the graph between these, we will get this type of graph. And you can also find the resistance of the wire by using this graph, because you know that R is equal to V upon I. So you can also find the value of resistance by using this graph. So this is the graph in between the V and I. Experiment to verify the Ohm's law. We will do this experiment in our school for the verification of the Ohm's law, in which I am going to explain you what we do in our experiment. We will have a voltmeter, a meter, a key, and a battery or a cell. We will have battery and connecting wire and thermostat. So first we will combine all these. We will assemble all these things together in an experiment. This is a connecting wire and we will have a resistance wire like this. This is the resistance wire. Okay? First, if you want to find the resistance of this wire, you will connect this wire to the voltmeter, because you should put the value of potential difference across this wire. So again, one thing you should remember that the positive terminal of this voltmeter should be towards the positive terminal of your battery. And this is your resistance wire on which you have to find the resistance. Now you will connect the ammeter in series with the circuit. And again, one important thing is positive terminal of the ammeter should be there towards the positive terminal of your battery. And then we will connect it with the key as well as the thermostat. This is the thermostat, and I explained you that we use this thermostat for changing the potential difference in the circuit. And how can you change the potential difference without changing the battery or cell? We know that we are by changing it worked as it changed the resistance of the circuit, not of this wire. Which resistance we have to find? We are not going to change the resistance of this wire, but we change the resistance of this whole circuit so that the potential difference changes and the current also changes. So okay, this is the thermostat and this is our key. This is the complete circuit. Now this is open key, and when you do not switch on, the current cannot be flow. So same as because the circuit is broken here. The circuit is not complete, that's why the current will not flow through it. Now, if you on the key, this is the on key, then the current will start flowing through the circuit. Now, what will you do? You will measure the reading of the potential difference as well as of the ammeter. And by measuring the units of these voltmeter as well as the ammeter, you will find the resistance of this wire by using the formula R is equal to V. And we will also draw the graph like this in our chart paper. So now you can also explain the conductor insulators on the basis of the resistance. So you can say the conductors are those substances which having the low resistance, and the insulators are those substances which having the high resistance. Okay, so we can also define the resistance, the conductors and the insulators on the basis of resistance. Now, okay, this is a very important part. The factors on this, the resistance of the wire. So now we are talking about the resistance. We know what is the resistance. We know the SI unit. How can we find numerically the resistance of the wire? What is the Ohm's law? And how can we find the resistance of the wire by using an experiment, by doing an experiment? Now, what are the factors on which the resistance of the wire depends? It's a very important part. Actually, the whole part is important. This whole chapter is important. So, the factors on which the resistance of the wire. Factors on which the resistance of the wire depends. The resistance of the wire depends on the length of the wire. First one, on the length of the wire. By increasing the length of the wire, the distance of the wire also increases. It means we can say that the resistance is directly proportional to the length of the wire. By increasing the length of the wire, the resistance of the wire also increases. You can explain, you can understand by using one example. This is your pipe, and there is a lots of stone in this pipe. Okay. Lots of stone in this pipe. And you want to flow water through this pipe. What will happen if you are taking the two pipes together, one having a long length and the other having a short? In which case the water will flow in a short period of time. Obviously in this case, yeah, we are taking one more example. Suppose you are on a very rushy road. There's a very lots of rush. Traffic jam. So you are on a road which is jammed by traffic, and suppose you have a two-wheeler. So you can easily find your way by two-wheelers. In four-wheelers, you are strict with the four-wheelers. The four-wheelers like atom, they can't move in a jam. But you can easily move out through your two-wheelers by taking your right with the two-wheelers. It is easy for you to move a distance. Suppose this is the road which you have to cover and having a traffic jam. And this is another path, a long path, and there is also a traffic jam like this. So which path you will use for covering a distance? Obviously first one, because the restrictions, the obstacles are less as compared to this one in the first case. Jitna kam length, utna kam resistance. So it means we can say the resistance of the wire is depends on the length. It is directly proportional to the length of the wire. By decreasing the length, the resistance also decreases, and by increasing the length, the resistance also increases. You also saw an example of bulb. Actually, these bulbs are not used nowadays. The old bulbs having a yellow light. So you have seen the resistive bands there like this. It is twisted like this. You know why? Because by making the figure like this, by making it like a spring, we are increasing the length of this wire. And when increasing the length, we know that the resistance of the wire also increases. Okay, this is a common example. You have seen the heater. Now, this is not so common. We use blower and turbo. So, in a heater, there is a coil like this. You know why the heater has this coil? Because if we are taking a straight line like wire this, the length of this wire is less as compared to this one. So, by making it shaped like this, the spring-like shape, we are increasing the length of the wire. And why we are going to increase the length of the wire? To increase the resistance of the wire. So, it means by increasing the length of the wire, the resistance also increases. So, we can say the resistance of the wire is directly proportional to the length. Second, this is area of cross section. Area of cross section. How does it depend on the area of cross section? It is inversely proportional to the area of cross section. Now, I am taking the example of road. Suppose there is a gate traffic jam and you have two wheelers to move through this jam. So this is a narrow, congested road, and this is a highway. Highway also have jam, but in which case it's easy for you to move. Obviously, on a highway because it is wide, and we have lots of space for moving through this jam, traffic jam. So, in the traffic jam, we will use the wider path. Why? Because the restrictions are less as compared to this one here. It means by increasing the area, the resistance decreases. So, it means the resistance is inversely proportional to the area of cross section. By increasing the area of cross section, the resistance of the wire decreases. So, that's why here in the case of bulb, we have a very thin wire. Have you seen a thin wire of bulb, a thin thin wire? Because a thin wire have high resistance and a thick wire have low resistance. So, second thing on this resistance of the wire depend is the area of cross section. Two more things on which the resistance of the wire depend. Next thing is the temperature. We can't say it is inversely or directly proportional to temperature because in case of metals, the resistance of the wire increases by increasing the temperature. So I am writing here the third factor, this is the temperature. So in case of metals, we can say that by increasing the temperature, the resistance of the wire increases. But in case of alloys, we are using alloys now. So in case of alloys, the resistance of the wire do not changes on changing the temperature. But on changing the temperature, the resistance of metals changes. It also is generally increases. So we can see the next factor on this resistance of the wire depend is the temperature. For metals, by increasing the temperature, the resistance of the wire also increases. But in case of alloys, the temperature can't change the resistance of a wire. So next time we use nitro as a heating element in the heater because nitro is an alloy and we know that in heater the temperature increases. So by increasing the temperature, the resistance of this heating wire, heating element will not changes. Now on to the next factor on which the resistance of the wire depends is the nature of material. This is the nature of material. Nature of material means some materials having less restrictions, or we can say resistances, as example copper, aluminium, silver. These are the metals having their own resistance, and some metals have a very high resistance like iron, lead. So it means difference resistance. Some materials having the low resistance, whereas some are having the high resistance. Now I am going to talk about the resistivity. So by taking these two equations together, according to the first equation, we know that resistance is directly proportional to the length, and according to the second, we find out that it is inversely proportional to the area per section. If we combine both these equations, so we will say R dash proportional to L. Here, L is the length and A is the area per section and R is the resistance of the wire. And we always know that if we want to remove the direct proportional sign, we have to place a constant here. So I am taking a constant rho. This is called rho. This is rho into L form. This is a constant. This is called rho. Is a constant. Its name is resistivity. Rho is the resistivity of the material. It do not depends length, area per section, either on the resistance. It only depends on temperature and the material. So resistivity do not depends on the length as well as the area per section, either on the resistance. It depends only on the temperature as well as the nature of the material. So okay, I am going to explain about the resistivity. I think it should be clear that what is the resistance and what are the factors of this resistance of the wire depend and how it depends on the different factors. Now let's talk about the resistivity, and we have numericals, lots of numericals, not lots of, a few numericals based on the resistivity, but which have lots of calculation. So okay, I am going to explain you the resistivity. So I told you that rho represent for resistivity, and the density of the material do not changes either of the length or area per section. It depends on the material as well as the temperature. By changing temperature, the resistivity also changes, but at constant temperature, the resistivity of the material always remains constant. So the formula for R is equal to rho into L point. This is the formula for resistivity. Or if you want to find the resistivity from this part, you can see that resistivity is equal to R into A upon N. Now, can you define this resistivity on the basis of this formula? Yes. So, take an example. Okay, this is a wire having the length of 1 meter. Now, what is the value of this L? This is 1 meter. And this wire having the area cross section is 1 meter square. So we can say that the value of A is also 1 meter square. So what should be the value of rho here? It is equal to R. It means a material having the length, suppose a wire having the length of 1 meter and having the area per section 1 meter square, the resistance of this wire at that temperature is called the resistivity of material. Now take another example in which we are taking the wire of the same length of 1 meter. We are taking 3 wires. This is the wire A, wire B, and this is the wire C. And all these wires having the same length, that is 1 meter, and having the same area cross section, that is 1 meter square. Now in this case, we will find out the resistance of this wire by using the Ohm's law. So the temperature, at this temperature, the resistance of these wires will be equal to the resistivity of this material. Since the resistance depends on the nature of materials, we can also say that the resistivity depends on the material. But the important point about the resistivity is that it do not depends even on the area per section or on the length of the wire. Resistance can be changes by changing the length of the wire as well as the area cross section, but the resistivity of the material remains constant. It do not changes either on changing the length of the wire or the area cross section. It only depends on temperature. Yes, by changing the temperature, the resistance of the wire, the resistivity of the wire changes. But the resistivity is the specific property of the material, since it does not depends on the length or area cross section. So what can be the SI unit of resistivity here? By using this formula, we can say that the resistance has the SI unit rho and area cross section is meter square divided by meter. So we will get ohm meter. Yeah, this is the SI unit of resistivity. So resistivity of the material is a constant property which does not depend on the length or area. It only depends on the nature of material as well as the temperature. The SI unit of resistivity is ohm meter. Okay. Now take one more example. Suppose this is a silver wire which having the resistivity 1.6 10 minus 8 ohm meter. This is a silver wire. And I am telling you the resistivity of this material is 1.6 into 10 to the power minus 180 minus 8 ohm meter. So what is the meaning of this statement? Since we know that the resistivity means the resistance of dead wire which having the length of 1 meter and having the area cross section of 1 meter square. So we can define this statement according to the definition of resistivity. It means that a silver wire having the length of 1 meter, having the area cross section 1 meter square, having the resistance equal to 1.6 10 to minus 8 ohm. It means we are taking the silver wire of 1 meter. As if the area cross section of this wire is 1 meter square. Then at the fixed temperature, I think this temperature is not given here. It's okay. At this temperature, suppose it is 20 degrees Celsius. So at this temperature, the resistance of the silver wire will be 1.6 10 to the power minus 8 ohm. Okay. So this is the meaning of resistivity. So now you know what is resistivity. This is a constant. On which factors the resistivity is divided by? How can we define resistivity? And what is the SI unit of resistivity? Now, we can also define conductors, insulators on the basis of resistivity. Now, it's become more easy for us to understand the the conductivity of material on the basis of resistivity. Since the resistivity of the material do not depend on the length or the area cross section, so we can say the conductors are those substances which have a very low resistivity. Resistivity is the resistance for a 1 meter length wire having area cross section of 1 meter square. So it means the wire having low resistivity means having low resistance is a good conductor. So it's not correct to say that the resistance is the specific property for material. We can say the resistivity is the specific property of the material. Resistivity, the conductors having a very low resistivity, whereas the insulators have a very high resistivity. So we are taking one more example for the insulators. This is a glass having the resistivity of 10 to the power 40 ohm meter. Oh my god, can you compare these values? It is 10 to the power minus 8 ohm meter and this is 10 to the power 14 ohm meter. So you can see the difference between them. The resistivity of a material, the resistivity of the insulators are so high that the current, the electrons cannot move along its path. So that's why the current do not passes through the insulators. And the semiconductors having the resistivity like this is silicon having resistivity 2300 ohm meter. So it is in between the conductors and insulators. So the resistivity of semiconductors are somehow less as compared to the insulators and large as compared to the conductors. Okay, one question from NCERT. It's a really important question. The question is why we use alloys as a heating element, not the pure metal. You have seen that the nichrome wire we use as a heating element as a heater, not the copper wire. So why we use as a heating material in heaters, they are heating appliances rather than pure metal. So you can answer this question on the basis of resistivity as well as the other factors I am going to explain to you. First one, you will say we use the alloy as a heating element because the resistivity of the alloy is large. So that's why we use the alloy as a heating element. We know that resistivity is also depends on resistance. So we can say the resistance is also depend on resistivity. If the resistivity of the material is high, it should have the high resistance. So alloys having the high resistivity. So that's why we are having the high resistance. And the heat produced, it depends on the resistance of the material. If a material having a resistance and the high resistance as compared to the conductors, yeah, we can say common elements, yeah, like conductors, metals. The resistivity of the alloys is large as compared to the metals. So we can say the resistance of the alloy is large as compared to the metals. And the heat produced depend on resistance. So by taking the large resistance, we can produce a more heat. The question can be there, why we don't use insulator which has a very high resistivity? So you will answer yourself, you will answer me. Why we don't use insulator as a heating element? If we need a high resistance, then we should use insulators. Insulators have very high resistance. Then why we don't use insulators as a heating elements? This is my question. Okay. So we are talking about why we use an alloy rather than a pure metal for as a heating element. So first one is alloys having a very high resistivity. And the second point is it do not get oxidized on heating. Alloys, you will learn this chapter. You will learn about the alloys in the last part of metal not metal. But I think it was related from your syllabus. So alloys do not oxidize even on heating. You know, mostly the metals oxidize on heating, like the magnesium and lead is oxidized on magnesium oxide. So it means metals oxidize on heating, but alloys do not oxidize on heating. So that's why we use the alloy as a heating element rather than a pure metal in the heating appliances. So this is the question why we use alloys in a heating element rather than a pure metal. So we will answer like this. First point you will write alloys having very high resistivity. And second one, the alloys do not get oxidized even on a heating. We do not get oxidized on heating. So that's why we use the alloy as a heating element and a pure metal. So okay, I will discuss numerical of resistivity, which is based on the formula R is equal to rho L upon. So okay, let's discuss the numerical based on resistivity of the next video. Yeah, we will discuss in our class since you will come from Monday on school. So we will discuss about resistivity, the numerical based on resistivity in next class. Okay, bye.